When solving a quadratic equation by completing the square, this is the process that we're going to be learning today. We haven't really done it yet. We've only done the second half. We create a perfect square factor on one side, with a constant on the other side of the equation. Since there is a perfect square factor, we take square roots of both sides. And just in the previous examples above, when I apply the square root, I must consider both positive and negative roots. This is so incredibly important. Why is it important? Well, I mean, your life won't be ruined if you miss it. However, you will get half the solutions to all the equations. In other words, maybe more importantly to you, you'll lose half the marks on every question where you forget this. So let's remember what we're doing, completing the square. We played this game earlier in the unit. What number am I thinking of in this first example? X squared plus 8x. Well, if you recall, I took this number, 8, I divided it by 2 or multiplied by half, same, and I squared it. So 8 divided by 2 is 4, squared was 16. So I would add 16 here. And the reason why I would add such a random constant, not so random, is that it creates a perfect square factor. Same thing over here. X squared minus 8x. I take negative 8x, I divide it by 2, and I square it. This would be equal to negative 4 squared. Again, I would add 16. Creates a perfect square factor of x minus 4 squared. All right, enough. Moving on quickly, x squared minus 6x, the number I would add is 9. Negative 6 divided by 2 is negative 3, I squared, it's 9. This factors, I've just created a perfect square factor of x minus 3 squared. Now, this one's kind of tricky, so I may choose to write out a little bit more. So I'm going to divide that middle term by 2. 13 divided by 2 is 13 over 2. Do not reach for a calculator. It will make your life worse. 13 over 2 squared is 13 squared over 2 squared. There's that exponent law again that I'm going to be using. And that is 169 over 4. My apologies for that writing. But when factoring out, we can see that this is x plus 13 over 2 squared. You may be asking, how did you factor that? Well, factoring perfect squares isn't today's lesson, but a nice way to remember it is, what was that number that you squared? The number that you squared was 13 over 2. It just so happens, in a perfect square factor, that's what it is. Now, the last two examples here, I'm going to play completing the square game. What cannot happen? If we notice, the coefficient in front of the x squared is 2. You can't play the completing the square game if the coefficient is 2. Uh-oh. So the one I have highlighted here, I can't complete the square. Similarly, over here, I cannot complete the square over here. Coefficient in front of the x squared needs to be 1, like those above. I guess I could write it like this, but it doesn't solve my problem where the coefficient in front of the x squared is equal to 1/2.